need to automatically add timestamps to tool calls without cluttering your AI interface. You'll see how arg transform with default factory handles dynamic values like timestamps invisibly, keeping your tool schema clean while ensuring every call gets the current time. The pattern uses a lambda to generate fresh values on each invocation, perfect for audit logs, analytics, or any scenario where you need contextual data without exposing it to the LLM.
Transform args equals timestamp arg transform. Hide equals true. Default factory equals lambda. Data time now.
This demonstrates the argument transformation pattern for tool adaptation. The concept involves wrapping existing tools to modify their interface without altering core functionality, creating specialized versions tailored to specific contexts. What makes this distinctive is its ability to bridge the gap between generic implementations and domain-specific requirements through declarative configuration rather than code duplication. The pattern works by applying a transformation layer that intercepts and modifies the tool's schema before execution. Hidden arguments with dynamic defaults, like timestamps, are resolved at runtime, while visible parameters maintain clean, LLM-friendly interfaces. This creates a separation between the tool's contract, what callers see, and its implementation, how it actually works, enabling progressive enhancement of existing tools. This approach matters because it solves the common problem of almost perfect tools that need minor adjustments for production use. Instead of rewriting or subclassing, you adapt tools through composition, reducing maintenance overhead. It's particularly valuable when integrating third-party APIs, legacy systems, or when creating specialized versions of generic tools for different user roles or workflows. Let's break it down line by line.
Transform args equals.
This initializes a dictionary to define argument transformations. It centralizes configuration for how each parameter should be processed, ensuring consistent behavior across function calls.
Timestamp arg transform.
This defines a timestamp argument transformation. It uses arg transform to customize how the timestamp parameter is handled, enabling automatic population with the current data time while hiding it from direct user input.
Hide equals true.
This hides the timestamp parameter from the public API schema. It prevents external callers from seeing or overriding the value, while still allowing internal use for automatic timestamp generation.
Default factory equals lambda. Data time now.
This uses a lambda factory to generate timestamps on demand, preventing all tests from sharing the same frozen timestamp. The lambda ensures each test gets its own current data time when accessed, maintaining isolation. Closes the dictionary definition for transform args. This terminating parenthesis finalizes the argument transformation configuration, ensuring the timestamp field uses the specified arg transform behavior with its hidden status and dynamic default value. Closes the dictionary definition for transform args, finalizing the configuration for automatic timestamp handling. This ensures the arg transform settings are properly contained and prevents accidental modification of the parent namespace. Dynamic argument transformation. The arg transform pattern in FastMCP 2 lets you surgically modify tool parameters without rewriting the underlying function, enabling runtime flexibility while maintaining type safety. Dynamic defaults via default factory only work with hidden arguments, since visible parameters require static JSON schema definitions. This pattern enables clean separation between AI-facing interfaces and implementation details like API keys or timestamps.
The argument vanishes from the schema becomes the most reliable argument of all.